First of all, residential for us was just kind of a toy problem that we chose. Our first market where we plan to deploy with a customer, with a design partner, is actually data center cooling systems.
Okay.
Which are still thermodynamic engines, right? So they're not that different from residential HVAC, but they're an order of magnitude more complex, obviously much larger, and a very interesting market because they're having trouble coping with demand from data center customers. And we're at a point where cooling systems are like the long lead item, right? Pacing data center development, which is kind of wild. So it is an acute pain point. It is in many ways, the delivery of those systems is in many ways limited by engineering bandwidth of being able to deliver sort of semi-custom solutions to each data center. And so we have a very enthusiastic customer base for that early deployment. And these systems are, these are now order 1,000 unique parts in the system.
Okay.
Right. The physics domains are quite rich, but the physics again are still pretty linearizable. Right. So from a synthetic data generation perspective, it's a fairly manageable problem, which is why we like it as a first vertical. And then we progress, and I think we progress principally on the basis of synthetic training data, this physics-based synthetic training data complexity. And so we our expectation is that we will go roughly an order of magnitude up in product complexity every year.
Okay.
So the second vertical is probably industrial systems.
Mm-hmm.
So things that go into a factory, from material handling, industrial robots, mills, lathes, right? Those kinds of things. Then we move into mobility domains, which could be automotive, it could be agriculture, mining equipment, right? Those kind of automotive and heavy machinery, and then aerospace and defense.
Yeah.
But just to give you sort of the order of magnitude progression, data center cooling systems, roughly 1,000 unique parts, airplane, roughly 1 million unique parts, right? So 3 orders of magnitude between them. And we think based on sort of our current projections is roughly 1 year for each order of magnitude.
How much of the data that's required